Okay, this is part one of planes in 3 space. We're going to talk about the scalar equation of the plane, which is represented by the equation ax plus by plus cz equals d. There are only 2 components to this equation. ABC is the normal vector, so the vector that is perpendicular to the plane, and xyz is any x naught, y naught, z naught, any point that lies on the plane. That creates the scalar equation. So let's look at the first example. Is the point 5, negative 1, 3 on the plane with the normal vector 2, 1, 1 that contains the point 4, negative 1, negative 2? Okay, so we have our 2 pieces of information. We have 4, negative 1, negative 2 as a point on the plane, and 2, 1, 1 as our normal vector. First thing we need to do is determine this equation of our plane, and we're going to want the scalar equation. ax plus by plus cz equals d. We have a, b, c, x, y, and z. We can plug all those values in and solve for d. That's our equation with our normal vector plugged in. And then I plug in my point to x, y, z, and I can find what our d value is. In this case, d equals 5. So now we have our scalar equation of a plane. (2x plus y plus z equals 5). What this means is that any point on this plane can be plugged in for x, y, and z, and the value should equal 5. So if 5, negative 1, 3 is a point on the plane, we can plug it into x, y, z and see if it equals 5. Plug our point 5, negative 1, 3 in, we get 10 minus 1 plus 3 equals 5. That's 12 equals 5. Since 12 does not equal 5, this point 5, negative 1, 3 does not lie on our plane. That's one example of using a scalar equation of planes in 3 space.